back to another video. Today we're looking at question 74, search in a 2D matrix. The way we'll be approaching this problem is by looking at the matrix, the sorted matrix, as not as a matrix, but actually an extended sorted list. So instead of this right here, 1, 3, 5, 7, in the second row we have 10, 11, 16, 20, and 23, 30, 34, and 60. Instead of looking at it in a matrix form, we will look at it as a big sorted list. And we will be doing binary search on this. So for example, we will be starting with, we'll be taking the mid of all of these elements, the middle index, and we'll compare that. And then if it is greater than the target, we will be moving backwards. If it is smaller than the target, we'll be moving to the front. But how will we do this, right? How will we figure out, just if we have mid, how will we map that to the rows and the columns? Since we know the number of columns and rows that we have, as soon as we have the mid index, so is that the mid index? So it'll be like either 11 or 16. So as soon as we have the mid index, we will say the way to actually retrieve that particular element from the matrix is by taking the mid index and dividing it by n. So that will take you to the row that has the index. And which column do we look at? We just take the modulo of that. So we're just doing binary search, but the mid index that we get with the binary search, we extend that to current row and current column using division and the modulus method. So let's jump right in. So if this isn't very obvious how you get the current row and the current column indices, I do recommend writing it all down and trying to walk through with examples. Awesome, let's get started. The first thing that we have to do is actually check for base cases, right? So let's check if the matrix, if it is null, or if matrix dot length equals 0, or since it's a 2D matrix, we would have to check for one more parameter if number of columns are equal to 0. If it is, if any of these conditions hold true, you want to return false. If not, let's get the number of rows and columns, right? So the number of rows would be matrix.length, and the number of columns would be equal to matrix of 0 dot length. Awesome. And then let's start with the left index and the right index, right? So the left index would be 0, and the right index would be equal to rows multiplied by columns minus 1. So what does this mean? This means when we represent it in a list form, like a sorted list form, one after the other, the last right index is represented by this number, right? So it's rows, the number of rows multiplied by the number of columns minus 1 is the last index in the list. Awesome. So we have a while loop, just like binary search. We have left if it is less than, while it is less than or equal to right, we have to do something, and we get the mid element, right? The mid element, as we know in binary search, it's right plus left divided by 2. Right. And then you check. Oh, but we need to actually get the indices. So let's get that. So int current column. Let's just copy this. So it would be int current row. In current column, it would be mid divided by the number of columns. So this will give us the row that we need to look at, and mid modulo columns will give you the column that we need to look at. So we check if a matrix with the index current row and current column, if it is equal to if it is equal to the target, you would return true. Else, you need to check if it is greater than or equal to. So you check if it is greater than the target, we need to move to the left. So wait, is that correct? So if matrix, yeah, that is correct. So that would be mid would be equal to right would be equal to mid minus 1. Else left would be equal to mid plus 1. Awesome. If none of this is hit, you don't return anything, but then you would return false in the end. Awesome. So let's run this, see if it's okay. The first test case looks okay. Everything else looks okay as well. Awesome. So let's talk about the space and the time complexity of this entire solution. The time complexity of the entire solution is log m plus log n. The reason why that is because we are minimizing the number of searches that we do, and we're using binary search to do that. So it will be an addition of log m plus log n. And then for space complexity, it would be O of 1, since we're not really using any additional space, and it would just remain constant. Awesome. So if you have any questions, please let me know in the comments below. Please don't forget to subscribe and like the video. It would really motivate